Subscribe to our YouTube channel and press the bell icon to get latest notifications.
Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to do our last chapter in our unit 3rd, and the name of that chapter is Fundamental Concepts of Algebra. A very important chapter, and this is one of the important branch of the mathematics, algebra. In this chapter we will come to know about the following terms. And the terms are, we will come to know about what is variable, what is constant, what are powers of literal, then we will come to know about algebraic expression, then terms, then factors, then coefficients, like and unlike terms, and lastly we will come to know about polynomial in one variable. So let's start with the word algebra. The word algebra is derived from an Arabic word, algebra. Which means a reunion of the broken parts, or we can say that restoration. And this word has been taken from a book, the title of the book, Kitabul Jabr wal Muqabala. And the founder of this branch and the name of that person was Muhammad ibn Musa al-Khwarizmi, who is called the father of algebra. Muhammad ibn Musa al-Khwarizmi. So from that Arabic word we take this word, that is algebra. And in algebra we will come to know about the following terms. We'll come to know about what is variable. If I define the word variable, they are the unspecified numbers, or we can say the unknown numbers. Whenever we have to find out the unknown numbers or unspecified numbers, that time we use the variables. And variables are the letters, or we can say that the small letters, like A, B, C, or X, Y, Z. The commonly used variable is X, which is used most of the time in the mathematics. Whenever we use to suppose something like let the value of this number, that time we used X, the most used variable in the mathematics. Although we can use any alphabet, A, B, C, X, Y, Z, any of them. But we use the most of the variable that is used commonly is X. So whenever we have the unknown quantities, that time we use the variables. And another name of the variables are literals. Next, constants. Constants are the numbers who never change their values. Their values are always fixed. Like we have integers, -1, 2, 3, either negative, either positive, or either 0. Whenever we have such kind of numbers, in algebra they are called the constants because they never change their values. And whenever we find the value of the variables, after giving the solution of the equation, we see that the value of the variable is also a constant. Move on to the next, that is the powers of the literals. When literals are multiplied by itself repeatedly, like x multiplied by x multiplied by x. Here we can see that here we have the repeated multiplication of the literal. X is to be multiplied by x is to be multiplied by x. So in short, we can write it as x. Here the x is called the base, and how many times the x is repeated? We can see here x multiplied by x multiplied by x 3 times. So we can use the exponent, which is 3. This 3 exponent or index means that x is to be multiplied by 3 times, and here the x is called the base. So the whole form is called the exponential form. So here x is called the base and 3 is called the exponent, or we can say that index. So in short, when a variable, a same variable is repeated itself, so we can convert it into the exponential form. That is called the powers of a literal. Now comes the next about algebraic expression. Now what is algebraic expression? An algebraic expression is the combination of constant and a variable connected with the operation like plus, minus, multiple and division is called an algebraic expression. For example, two x plus 3y minus 2. So here we can see that we have the constants like 2, like 3, like 2. They are the constants. And we have the variables x and y. And they are combined with the plus sign. And between 2 and x we have the hidden sign, that is a multiplication. So when we see such kind of expression, that is called an algebraic expression. And in the algebraic expression we see the parts, like we have 2x, we have 3y, and we have here minus 2. So the parts in the algebraic expression are called the terms, which is our next topic. So whenever we see the parts in the expression which are connected with the plus or minus sign, only plus and minus sign can divide a part. The parts can be divided with the help of the plus or minus sign, neither multiplication sign nor division sign. Whenever we have to divide, we have to separate the terms. That time we can use a plus sign or minus sign. So in this expression we can see we have 3 terms, 2x, 3y and 2. Here this term 2x is basically the combination of 2 multiplied by x. The term, the part 2x, if I separate it, we have the combination of 2 and x with the help of the multiplication sign. So we can say that this term is the combination of the factors. So we can say that 2 and x are the factors of this term. Similarly here 3 and y. So we can say that this term is the combination of 3 and y. So we can say that the 3 and y are the factors of this term. And here we have the only single term, that is 2 without a variable. And when we see such kind of term without a variable, that kind of term is called a constant term. And we have the next, that is coefficient. We can say that 2 and x. Here the 2 is the numerical coefficient of x, or we can say that x is the literal coefficient of 2. So whenever we have such kind of situation, like I will give you one more example, 2x square y. So here we have 2x square y, a single term, because we don't have here plus or minus sign. So if I expand it, 2 multiplied by x multiplied by x multiplied by y. So in this term we have 2x, x and y. These are the factors of this term. And 2 is only here the numerical coefficient of x square y. And x square y is the literal coefficient of 2. So in this term we have 2x, x and y. They are the factors, and 2 is the numerical coefficient of x square y, and x square y is a literal coefficient of 2. Move on to the next, that is like and unlike terms. To identify whether the terms are like or unlike terms, at least we need two terms. For example, 2x square y, and we have one more term, 3x square y. Whether the term are unlike or like term, what we have to check? We have to check the the literal part. If the number of variables are same, here we can see x square y, x square y. Both the terms have the same variables. Then if the name of the variables are the same, here we have x, here we have x, here we have y, here we have y. So the name of the variables are same. Plus one more thing which is very important to check whether the term is a like term, the power of the variables should be same. Whatever is the coefficient, the numerical coefficient, doesn't matter. If the numerical coefficient are same or not same, here we have 2 and x, they are not same. It doesn't matter. To check whether the terms are like or unlike, we need to check the variable part. If the variable parts with having the same power, x square having the power 2, y and y having the power 1, so we can say that these terms are like terms. So to check whether the terms are like or unlike term, what we have to check? We have to check the variable part. If the variables are same and their powers are same, so we consider them as like terms. If one of the condition is violated, suppose 2xy and 2x square y, x square y square. Another example. Here the variables are same, xy, but the powers are not same. The exponents are not same. Here the exponent is 1 and here the exponent is 2. So we can't consider them because they are same. The variables are same, x and x, but the powers are not same. So we can't consider them. They are like terms. They are considered as a unlike terms. So when we need to check whether the term is a like or unlike term, we have to check the variables. They should be same, as well as their power should be same. So when the terms are having their variables same as well as their powers are same, so we consider them, they are called the like terms. Move on to the next. Polynomial in one variable. First, understand what is a polynomial. An expression, when we have an expression having the constant as well as variable, and most important thing when we need to check whether the polynomial, whether an expression is a polynomial or not, we have to check their variable parts. If the power of the variable is a whole number, means the variables having the power non-negative, means the variables whatever is in the expression. Suppose 3x plus 3y. I'm given an expression 3x plus 3y. We have the variable x and variable y with the power of positive. Means the powers of the variable should be positive. If you have such kind of expression having the power of the variable positive, we can say that the expression is a polynomial. And on the basis of the terms, we have different types of polynomials. Like we have monomial, we have binomial, depending upon the number of terms in that expression. We have trinomial. When we see an expression having a single term, that expression is called a monomial. For example, 3x, a single term expression. So this expression is called a monomial. 2x plus 3y. Here we can see in this example, we have two terms in the expression. So this expression is called the binomial, depending upon the number of terms in the expression. And one more example, 4x plus 3y plus 2. Here we can see in this example, number of terms in this expression are 3, because terms are separated with plus or minus sign. So we have 4x plus 3y plus 2. Here the number of terms are 3. So depending upon their number of terms, it is considered as a trinomial. Generally they are all called the polynomials. I hope you all understand this topic very well. Let's move to the exercise. Exercise 1 of this chapter. Question number 1 of exercise 1 of algebraic expression. It is express the following using algebraic symbols. Very easy questions. We have to frame them as an algebraic expression. Question number 1 part first. It is sum of a and ten. This is a question. Now we have to show it in the algebraic form. Here it is written as sum of a and 10. So how we can write it in the algebraic form? Sum of a and 10. Sum, instead of sum we can use 10. Plus sign. So a plus 10. This is the answer of this question. So here it is written in verbal. So we have to convert in the algebraic form. The algebraic form of this statement is a plus 10. Similarly, part third of the same question, I'm showing the order into parts. 10 added to r. Again, this statement we have to convert into the algebraic form, which is equivalent to 10 added to r. So r plus 10. In terms, here the word is used added. So we are going to use a plus sign. So r plus 10 is the algebraic form of this statement. Similarly, part 5th of the same question is p reduced by 30. Again, this statement we have to convert in the algebraic form. Reduced means kam karna. So we have the sign that is minus. So p minus 30 is the answer of this question. So this was question number first, and you will suppose do the rest of the parts by yourself. Question number 2 is same. Question number 3 is same. 4 is same. I'm going to show you question number 3. Part first. Express algebraically 10 kg lighter than x kg. So we have to convert it in the algebraic form, and the statement is 10 kg lighter than x kg. So we can write it as x minus 10 kg. So this is the algebraic form of this statement. Next one is part third. 5 more than x. Rupees 5 more than x. So x plus 5. They are the statements you simply need to convert in the algebraic form. and the part 15 years younger than x years. So x minus 15 YEARS. So this is the statement. This was a statement, and we have to convert these statements into the algebraic form. So here we get the algebraic form of these statements. I hope you all understand this topic very well. See you in the next video. Till then, wassalamu alaikum wa rahmatullahi wa barakatuh.